So, welcome everybody. I'm Nicolai from the Smagt, as you just mentioned. I'm a network design engineer for Infradata in the Netherlands. We are a network integrator focusing exclusively on the service provider space, with offices now in the Netherlands, Poland, Belgium, UK. We partner with many of the large vendors of service provider network equipment. We've especially strong partnership with Juniper Networks. As you see, we won the Service Provider Partner of the Year award this year. And I'll be talking to you a little bit about IPv6 transitioning and the mechanisms and technologies that exist to help you with making the move from an IPv4 only network to an IPv6 enabled network. Okay. Better? Okay. So you can't start an IPv6 presentation without mentioning why. The obligatory slide, as I call it nowadays, because all these presentations always have this slide in there. I just have one slide. It used to be like 10 slides explaining why you need IPv6. Well, now I guess it's clear to most of you guys that it's coming and there's no way to stop it. Anyway, just put this one slide in just to recap. First of all, of course, IPv4 address space is starting to be exhausted. The international IANA already doesn't have any address space left. RIPE has a couple of /8 networks left to allocate, but it's not much. Hopefully you guys have been reserving and making sure that you have some allocation free left in your bag that you can use later on. But anyway, they will not last forever, and at some point everybody will be out of IPv4 space, and we need to look at alternatives, which is why IPv6 exists. Nowadays there's an external driver as well, which is getting more and more important, and that's actually that there's demand coming now for IPv6. Demand by end users who want you to provide them with IPv6 lines, connections, and content. There's content now available over IPv6, more and more. Last year we had the World IPv6 Day, where some big players, they turned on their quadruple A records, meaning that they were announcing their IPv6 presence basically, and it went without a problem actually. So that learned us that okay, we can turn up this IPv6 presence, and that's what's about to happen, because on the 6th of June there's World IPv6 launch, meaning that large players like Google, Facebook, they will actually start to tell the world that they are IPv6 enabled, and that if you have an IPv6 connection, please connect to us via IPv6. That's a big thing actually, because that will really drive the uptake of IPv6 traffic, and that's really important. Also, there's that World IPv6 launch also means that some access providers will actually start by default handing out IPv6 addresses. When a customer calls and asks for IPv6 service, you really cannot tell him that, well, we never had anybody else ask for it anymore. That time has gone now. So, well, the good news is about IPv6 migration that usually the networking guys, they have the easy part, because you know what's about to happen, you know what kind of mechanisms exist to help you making the move. And it's relatively clear. The hardest part usually is not for you guys, but it's for the IT guys and the people that have software in which maybe IPv4 literals are used or other problems. There's all the backend systems like radius databases that need to be updated. Procedures like procedures where IPv4 literals are used, or even the yellow stickies on the side of the NOC terminal. That's really a lot less predictable than what you guys are facing. So count yourself lucky. Couple of words about strategies that we are seeing service providers in our region, which is the EMEA region, implement today to make the move to IPv6. In general terms, you can have either a conservative or a progressive kind of strategy. Conservative being, okay, let's stick to what we know, let's try to make the most use of our IPv4 kind of paradigm that we have in our network. Let's not change too much, so we have some time to slowly make the move to IPv6. As I said, usually these are the big players, the big carriers that need to be conservative because they don't have all the flexibility in their operations to be progressive about it. The progressive strategy is usually for the smaller players that are able more easily to move their operations from v4 to v6. They tend to want to deploy IPv6 a bit more aggressively and ideally get rid of IPv4 as soon as they can, as soon as they no longer have a business need for it. I'll get back, I'll talk to you about the technologies that can help you in defining these strategies, and then I'll get back to the slide at the end of the presentation. So, what kind of technologies do we have to help us go from v4 to v6? Well, there's actually two kinds of things that you may want to do. You may want to try to stay on your v4 space as long as possible, mitigate the exhaustion problems that could occur with IPv4. That's what large-scale net, or actually double net 444, so net 444 is for. There's tools to help you deploy IPv6, like just simply dual stack, just basically turn on IPv6 in your network. And there's all kinds of tunneling techniques like 6RD that can help you deploy IPv6 over an IPv4 network. And there's tools that do both, actually. Those are the interesting ones. Dual stack Lite and Net64, they can help you deploy IPv6 and manage your IPv4 address resource problems at the same time. So these are actually likely the most exciting technologies. A few words about Net 444. Large-scale net. Basically, what this is adding a layer of network address translation in the service provider network at the edge. So you can actually move your public IP addressing into private IP addressing, saving you all the CPE IP addresses that you're handing out. That, depending on your size, that's usually a very large amount of space. So that's good. It saves you space. Of course, you need to do net on all your customer traffic, and that's a bit of a disadvantage. Because you have some challenges with net, as I'm sure most of you guys are aware. You have like applications that tend to break using net, so you need to do smart things about it, like using ALGs, application layer gateways, to fix protocols that don't like net. And even then, other protocols might break. So it's always a problem, especially when you're already doing net at the CPE level and you deploy an extra level of net at the service provider edge. Yes, you have dual layer net, which makes it even worse. Another problem with large-scale net is that when you do this double net, there's always a chance that the end user might be using the space that you are actually deploying in your as your private space, as your private large-scale net space. So then you have a collision of IP space, and basically the customer connection doesn't work anymore. There's the problem that when you do end user to end user connection through your private space, the customer that receives the traffic might drop the traffic because it's private range, and he has access lists that drop private range traffic on his outside interface. So you need actually to route all this traffic all the way up to your net box on the edge of your network and then back down again, so you can do translation on this traffic. And then of course there is effects on, let's say, the availability of your network, because you're applying an extra point of failure in your network. And that's stateful, so that's even worse because it's vulnerable to DOS attacks and it's vulnerable to all the regular things that hinder availability. Last point I'd like to make is that port forwarding is no longer easy. Port forwarding is easy to do if you control the net, but if you want a customer to control your port forwarding on a large-scale net, then you have a problem. There's protocols coming to make that happen, but right now that's kind of tricky. So how to enable a customer to run a server, say an SMTP server? It's kind of hard to do. Just a quick drawing on large-scale net. Basically, this is what large-scale net is about. So the big yellow bubble would be your service provider network. You already employ net at the CPEs, but now you also put an extra layer of net where the blue router is. So you would have a double layer of net. I just put in a couple of slides with some Juniper config, just really short to give you an idea that is actually pretty simple to configure on these boxes. A large-scale net functionality is available on all Juniper M, MX series routers. It's also available on SRX firewall series. This config example is specific for MX routing, but it's practically the same on all the product lines. First you configure some, well, let me just explain the topology first. So actually on the left you would have your customers running CPEs with private address space in the 10/8 range. In the middle where it says CGN, CGN is actually carrier grade net, that's an old term for LSN. That's the box that we configure for net, and on the right is the public internet. So you would configure an inside interface going to your customers. On this inside interface you would configure the service set as set 2 in this case. This is actually what sends traffic to the service line card, which is responsible for doing net. You always need to have a service line card if you want to do net on a router, because of all the network state that's involved. You need to have a separate line card for it that you configure here. That's SP5. Anyway, you send the traffic on the inside interface towards the multi-service line card using the service set, and you configure an outside interface to the public internet. And then you configure net. And you configure net by configuring a net pool, a net rule saying, okay, I want to match traffic coming from my CPEs in the 10/16 and 10.1/16 range. I want to translate it to that source pool, and you configure the service set where you say, okay, apply these net rules to my traffic going on the multi-service line card. Something about protection. You can, of course, protect your control plane because, as I said, it's vulnerable. You're vulnerable to network state attacks and problems. So you can limit in the services IDS stanza. You can limit sessions to or source IP addresses to a maximum number of sessions. In this case, 1,000. And in the applications stanza, you can specify a timeout per protocol, so that you can control the amount of open sessions in your box. This is just a really basic config. If you need more than this, you can contact me offline, or we can work on that. Just some really quick words about all the tunneling stuff that well, is in use today. This is another way to provide really quick IPv6 service to your end users. You can do these like 6RD, or there's IP. There's all kinds of tunneling mechanisms. The idea is, okay, I only have an IPv4 network. Still, I want to provide quick IPv6 service to my users. Well, then you can set up a border relay, 6RD border relay, and you can tunnel traffic over your IPv4 network. Basically, what I can say about this is that this is actually yesterday's technology. This was used in the time that IPv6 was for research only, and people wanted to be able to connect over tunnels. Nowadays, most people won't accept this anymore as a solution, and I really think that you should look for something more structural as a solution to your IPv6 migration. Because actually this doesn't solve anything, because you still only have an IPv4 kind of internet connection, and you still need to migrate at some point to IPv6. So the next technology that will help IPv6 deployment is dual stack. Dual stack is really simple. You just enable IPv6 in your network and connect your customers both to the IPv4 and the IPv6 network. Usually on the same CPE. This is really nice. If you can do it this way, please do it this way, because this way you will be sure that you do not run into any of the issues that you have with NAT and other kind of technologies. But the problem is that you still have to hand out an IPv4 address to every single one of your customers. So if your problem is that you are lacking IPv4 address space, you don't solve it with going dual stack. Then you really need to look at something else. Also, you have to realize that each of your boxes in your network will run an IPv4 and an IPv6 stack and routing information base, and this will be more intensive on the boxes, and if you have old boxes it could mean that you would have to do hardware upgrades. So this is a dual stack. It's really simple. The big orange bubble is your network this time, and you just turn on IPv6 there, and you give you find an IPv6 native transport somewhere, transit connection, and you hand out IPv6 to the CPEs of your customers. Of course, you need to realize that the CPEs of your customers need to actually run IPv6. They need to be able to run IPv6. So then there's DS Lite. DS Lite is a lot like dual stack. That's why it's called dual stack Lite actually. You can give your customers at the same time IPv4 and IPv6 connectivity. Also, you can run this on a completely IPv6 only network, so you can actually turn off the IPv4 addressing in your network. And it also solves the problem of address exhaustion, because you can not perform NAT on that traffic. So this is actually a really interesting deployment, because it fixes almost all of your problems. Except there are some disadvantages, namely you do NAT, so you have all the problems that you have with large-scale NAT. And your CPE needs to support this, and that's still a bit tricky, because there's not many CPEs that do reliable DS Lite today. It's getting better though. Okay, so how does this actually work? Well, now you have the blue bubble, which is again your network. This is an IPv6 only network, so you don't have any IPv4 in your network anymore. Only IPv6. That means there's no problems with IPv6 address exhaustion. That's the good news. The CPEs, customer CPEs, are v6 only, so they only have a v6 address on their outside interface. On the inside, they have IPv4 and they have IPv6. If the customer decides to send IPv6, it will be transported natively through the network. If it's v4, the CPE will understand, because it's a DS Lite capable CPE, it will understand that it's v4, and it will actually tunnel this traffic. It will put a v6 header around it, and it will send it to a certain box in your network somewhere. That's a DS Lite concentrator. Basically, it terminates from each of your customers. It terminates a tunnel. It looks at the traffic. It understands that it's from a tunnel. It will strip off the IPv6 header. It will perform again large-scale NAT, and it will send it away on the IPv4 internet. So this is actually a combination of large-scale NAT and dual stack, I would say. So the good news is You don't have IPv4 address exhaustion. You have an IPv6 access network, only IPv6. You have only one level of net, while with net 444 you have two levels of net, so that's even worse. Well, the biggest drawback is, of course, that the CPE needs to know how to handle this, and that can be tricky. And if you have a large install bases of CPEs that don't support DS Lite, well, then it's a bit tricky to implement this. Just another quick configuration for DUNOS. In this case, on the left we have the CPE, the thing that's labeled B4. B4 is actually the term to describe DS Lite capability, more or less. That's the CPE. The blue box in the middle is the box terminating the DS Lite soft wires. And on the right is the public internet. Okay, so we configure this DS Lite box using an inside and an outside interface. Again, you have the same kind of service sets where you push the traffic coming in on the inside interface towards the multi-service line card, which is here. This time you also configure family INET 6 on the interfaces because it's IPv6. And you configure an outside interface with the IPv4 address on it. This is basically exactly the same as it is with net 444. Again, you specify a source pool and you specify rules that tell the box how to translate traffic. The only thing extra compared to net 444 is that you do this soft wire configuration in where you tell the DS Lite concentrator box exactly which tunnels to terminate and how to terminate the traffic and how to translate it on its way. So just a quick look at net 6.4. Net 6.4 is another technology that can help you with both things, both translate or IPv4 address exhaustion and IPv6 deployment. This is an IPv6 only technology where you only have an IPv6 network. And you have smart DNS servers that basically reroute, tell customers how to reach IPv4 traffic over the net 6.4 netbox. This will be in place probably, this looks like the technology that will be in place for a long time. Once networks are IPv6, but there's still some IPv4 content out there to reach this content over an IPv6 only network. Okay, let's skip this. This is what DNS 6.4 is about. DNS 6.4 is a trick where basically you ask over an IPv6 only connection, you ask your DNS server for content that's IPv4 only. The DNS server will receive upstream from the content provider a normal IPv4 address. It will change that DNS answer to an IPv6 quadruple A record. Within it, the prefix that the net 6.4 net gateway is reachable by, and it puts the IPv4 address in there as well. So the net 6.4 box will understand where to route the traffic to. And this is how we get traffic to the net 6.4 gateway when we have IPv6 only and we receive IPv4 DNS entries. About the config of this service, again, really simple network. This is just an example, and if you want to know more about these kind of configs, contact me. This is the config of the netbox that's in the middle that sits between the IPv6 only host on the left and the IPv4 only host on the right. There needs to be a DNS server in there, as you can see on the top. I'm not showing you the config of that box. It's really similar to what we saw before. You have INET 6 service sets that move the traffic to the multi-service line card. And you have an outside interface that's IPv4 only. This is the NAT configuration. The only thing that's extra is the destination address. that's actually that prefix that can be used, that is used by DNS64 to route traffic to that networks. So every DNS64 quadruple A reply will be in that specific range 64 FF9B. That's the trick, I would say. And the service sets is where we put everything together, the NAT and the right multi-service line card and something about syslog. So back to this slide, strategies. We saw before that there's a conservative way to do it and a progressive way to do it. The conservative way to do it is to stick to your IPv4 space as long as you can. You would use net 444 for this probably. Then at some point you must have native IPv6 just because all your customers demand it basically. Then usually these kind of companies will start with a dual stack deployment, so they will just put IPv6 next to their IPv4 existing network. They will start at the core to gradually go into this new technology. Finally, when they're done doing dual stack and the IPv4 service is no longer required by their customers, they will turn off this IPv4 service, will only deploy IPv6 services, and then they will use net64 for the access to the long tail of IPv4 content. That's generally what we see being done by large carriers today. Some people take a different route, but most large carriers are looking at this as their strategy. The progressive way, which is the nicer way, if you can do it progressively. And we see this being done by hosters, by content owners, by those kind of players. Usually they want to deploy IPv6 as soon as possible and just get it over with and get rid of IPv4 as soon as they can. For this they start today deploying IPv6 on the edges, so they can already start offering IPv6 services to their end users ASAP. This gives them actually a competitive advantage, because you're able to today, if you're able today to deliver native IPv6 service, you have a unique position. At some point, they will actually be able to switch off their IPv4 native network and do it the DS Lite way, using these DS Lite concentrators to actually move tunneled IPv4 traffic, so they don't need their own IPv4 network anymore, except of course in the edge. And finally, they will do the same step, which is just the same step in any v6 strategy. That's turn off IPv4, forget about it, and deploy a net64 gateway somewhere for access to the long tail of v4 content. This is the preferred approach. If you can do it progressive, please do it progressive, because you're future-proof from the start. As soon as you deploy IPv6, it's there. You have less network address translation in your network, because you have only a single layer with DS Lite and not a double layer like it is with net 444. You're able to sell IPv6 services sooner, and you don't have dual stack, which could lead to scalability and some complexities in your network. Conclusions. First of all, you're lucky because you do networking, and it's actually simpler to do the networking move than it is to do the IT and the process move. Make sure that everybody in your company is aware of that and they're not just looking at the networking bit. If you can do it, please go dual stack. If you don't have exhaustion issues, dual stack is the easiest way to do it. If you can't do that, maybe DS Lite is an option for you, but that really depends on your business model and whether your CPEs actually will ever be able to support DS Lite. If you can't do DS Lite, well, then net 444 probably is what you have to look at, but that has many problems and would be a kind of a last resort solution. And finally, I talked a little bit about net64, which appears to be the end game technology that everybody will be implementing for years to come to access IPv4 content when the network is IPv6. And that's it.
Thank you very much for your presentation.